Hello everyone. Today we are here to talk about centrifugation. We'll be just giving a brief introduction to the topic as to what is centrifugation and what can be the differences between sedimentation and centrifugation. What are the basic factors on which centrifugation depends? So what is centrifugation? Well, if you have a solution that doesn't settle down under gravity on its own, then centrifugation is essentially the spinning of this solution vigorously to create something known as a centrifugal force that allows the particles to settle. This technique was in the very beginning implemented by a Swedish chemist called Theodor Svedberg. Now, this fellow was specially gifted in physics and chemistry, and in fact, he ended up earning his bachelor's degree within a year at Uppsala University. And at the time, he was conducting research on something known as colloids. Basically, colloid is a solution in which the solute molecules are so small that they are being constantly jostled around by solvent molecules and do not settle under time. At the time, there was a debate going on in the scientific community as to whether or not proteins are individual aggregates that would settle or they are just another colloid. To settle this debate and also to conduct further research on colloids, Theodor Svedberg then invented something that he called the ultracentrifuge. Now, ultra here does not refer to the present day centrifuge. In fact, it was just a name that he gave to the centrifuge that he developed this contraption here. This was able to reach up to velocities like centrifugal forces 5,000 times the gravitational acceleration, and in fact, it did lead to many catastrophic accidents in the lab when metal shards would be hurled around the laboratory. But he did ended up proving that proteins are in fact molecules, and for that he earned a Nobel Prize in chemistry. So let's just take a break from all the science and relax at the beach. I think you guys can relate to something that would have come to your aid in fun times like these. That is the bucket. This bucket is a really good tool to understanding centrifugation. For instance, if you have a bucket full of sand and water, now two things can happen here. You can either allow the sand to settle on its own in the water, or you can whirl the bucket around or swing it around yourself. So if the bucket is left standing, something known as sedimentation happens. That is, the solute molecules will settle due to the gravitational force very slowly. However, if you swing the bucket around, something known as centrifugal force comes into the picture, and this allows the molecules to settle very fast because centrifugal force is in fact a multiple of G and is much faster acting than sedimentation. So what affects centrifugal forces? There are three properties that affect centrifugal force. One is properties of the particle, the second is the properties of the medium in which the centrifugation is happening, and the third is the centrifugal force, that is how strong is the force that you applied. Under properties of the particle, the first thing that we talk about is particle density. So just common sense dictates that if you have something that is denser, for instance a stone compared to a ball of yarn, the stone would settle much faster. If you have two objects that are more or less the same density but they differ in size, so for instance we have an ostrich egg here and a hen's egg, then the ostrich egg would settle much faster than the hen's egg. If you have two things which are essentially same in all other aspects except the shape, anything that is less varied in shape and more uniform, for instance a sphere would settle much faster than an elongated shape because it experiences more friction. Now, in properties of the medium, the two most important properties that affect centrifugation are density and viscosity. So, if you have water and honey, water will allow centrifugation to be achieved much faster in a much lesser time compared to honey because water offers lesser friction because of lesser viscosity. Now, you remember the bucket that you were swinging? Okay, so if you offer more revolutions per minute, that is you swing it more like with a higher velocity. For instance, if you have 1,000 revolutions per minute of the bucket, then the centrifugal force generated is higher and the particles would settle much faster. Alright, so that's all for today. And for the next presentation, we'll be talking about the principles of centrifugation, mostly concentrating on Svedberg coefficient and the time taken for centrifugation and the terminal velocity. Thank you all. See you later.